Assalamualaikum. Today we would like to present about pre-stressed and precast concrete. We consist of 4 group members. First, I will present Nurul, Husna, Binti, Azmi. Second presenter is Qamarina. Then Ezza, Dyana. Lastly, Nur Aina, fatehah. First and foremost, the concept and principle of pre-stressing that are being adapted in pre-stressed concrete is putting compressive stress into the structural member before it's put into service. This compressive stress induced by high-strength steel tendons in a concrete member before loads are applied will balance the tensile stresses imposed in the member. The effect of pre-stressing is to reduce the tensile stress in the section to the point till the tensile stress is below the cracking stress. When the reinforcement is pre-stressed, it will reduce deflection and increase the strength. As we know, traditional reinforced concrete is brittle and has no strength against tension. Therefore, it easily cracks when maximum load is applied. Based on this diagram, when we apply maximum load on concrete member, it will bend. The top part of the concrete develop compression, while bottom part develop tension. Due to this elongation at the bottom concrete, it will easily get cracked. Pre-stressing is done to have longer span, lower depth, increased strength and tensioning the reinforcement. For example, if we try to construct this bridge with reinforced concrete, then we will have to increase the depth of span, so there will be not enough space under the bridge for ship to pass through, and also using a lot of material like concrete.
As we all know, pre-stressing is a process of tensioning the reinforcement. Pre-stressing is needed to avoid cracks, increase the strength, and also reduce the deflections on the concrete structure. Usually, in a normal reinforced concrete, when a load is applied onto the concrete structure, the deflection will occur. The compression will occur on the upper part of the concrete structure, while tension will occur onto the bottom part of the concrete structure. Due to these elongations on the bottom part of the concrete structure, it will causes the cracking to occur. This is why in pre-stressed concrete, the steel bar is placed onto the bottom part of the concrete structure. The steel bar will be stretched so that it will resist most of the tension. The compression will also generate at the bottom part instead of the upper part of the concrete structure. The upward forces will counterattack the service load applied on the member. Thus, it will save the concrete from cracking. Pre-stressing can be divided into pre-tensioning and also post-tensioning. In pre-tensioning process, steel is stretched before the concrete is placed. It is a factory-based operation, so it will be constructed in the factory first and will be transported to the construction site later on. Firstly, in pre-tensioning, the tension is applied to the pre-stressing tendons against the end abutments. The tendons will be stretched about 70 to 80% of the ultimate strength. Next, casting of concrete will take place where concrete is poured around the tendons and allows to cure. Once concrete achieves the required strength, the stretching forces are released or the cutting of tendons are done. Concrete will also get compressed due to the highly strength steel placed on the bottom part of the concrete structure. Moving on to the post-tensioning process, steel is stretched after concrete hardens. It is carried out on the construction site. In post-tensioning, casting of concrete will take place first. The concrete is casted and allows to cure. The duct is placed into the concrete structure, and when the concrete reaches its required strength, the tendons are stretched and locked with anchor. The excess ends of tendons are then cut away, and the duct will be grouted and covered with concrete. This is to ensure that there will be no rusting occur in the future.
Assalamualaikum, my name is Ezza and I will be presenting on advantages of precast concrete over conventional in-situ construction method. The first advantage is time comparison. Precast concretes are delivered on-site in an expected period, reducing unnecessary handling and equipment use, which consumes less time compared to the cast in situ method. Precast concrete also requires shorter time in during finishing works, as the electrical piping work is already fitted in the precast walls and slab. Cast in situ method requires a longer time to be prepared, as concrete needs a minimum of 28 days to achieve its maximum strength. Next, the advantages of precast concrete over conventional in situ construction method is on cost comparison. Precast concrete are usually done in a bulk, thus reducing the cost of production. Precast concrete also produces concrete with more durability, sound durability, and more flexible with a smaller cost compared to the cast in situ method. Precast concrete also requires less maintenance cost or fee than the cast in situ method. Lastly, the advantages of precast concrete over conventional in situ construction method is on productivity. The productivity of construction using the precast concrete is higher compared to the cast in situ method, as it requires shorter time of installing the structural components. The precast concrete also produces less variability of products, which means that the products are more consistent than the cast in situ method. The precast concrete also has a lower efficiency loss due to smaller workforce required.
Okay, after that, how precast concrete construction can contribute to reducing carbon dioxide and global warming issues. As we all know, precast concrete is a construction product that produced by a casting concrete in reusable mold, then cured in a controlled environment. Since precast concrete produced at a factory or a manufacturing site, this carbon dioxide emission can be reduced, hence the global warming issue also can be reduced. The CO2 is mostly generated during construction, that is during manufacturing, transportation, production, and installation of the building members. Since the precast concrete made at a factory before transport to the construction site, it is surely can control the environmental issue. The precast concrete surely can reduce the emission of carbon dioxide, since the power consumption associated with the use of electricity and fuels for the device and equipment was decreased. As we all know that all the device and equipment such as crane, machines will produce the carbon dioxide and heat that may lead to the global warming. After that, the carbon dioxide emission can be reduced because of less material are used in a construction phase when we use a precast concrete for sure. Materials such as cement mostly, which can contribute to higher emission of carbon dioxide. The emission of carbon dioxide surely can be reduced by 75% and until 80% compared with the conventional building, which is reinforced concrete, due to the decreased amount of reinforced concrete bars in a building, as said Hahn et al. Okay, after that, it was expected that an adequate carbon dioxide reduction can be accomplished based on a reduced number of structural members, so that the precast concretes are very benefits uh, in a construction because of can reduce the carbon dioxide emission, also can reduce a global warming issue for sure. Here's a example of the precast concrete, which is a precast slab.